Hi, okay, so these word problems are from chapter 8. So the first one, Carrie is pulling her luggage across the airport floor. She applies 22 newtons of force with an angle of 72 degrees with the floor. What is the magnitude of the force that moves the luggage straight forward? So if this is the floor and this is 72 degrees and there is a 22 Newton force, let's call that F. So what we want is the force that moves the luggage straight forward, meaning I want this one right here. That's the X component. And then this is the Y component. So one way we can label these, instead of just X and Y, because these are the X and Y components of the force, I can say this is F sub X and this is F sub Y. So what we want here is F sub X, which is 22 cosine 72, and that's 6.798 newtons. And then it says, what effect would it have if she moved the handle closer to the floor, right? So you can see if the handle moved closer to the floor, decreasing the angle, what would happen? Well, then this force would increase, right? So there would be an increase in the horizontal component because as the angle gets closer to 0, the cosine obviously gets bigger. Okay, so here, two people are carrying a box and one person exerts a force of 140 pounds at an angle of 65. The other person, a force of 115 pounds at an angle of 58. Find the net weight of the box. So now when we talk about net weight, this is how much force it takes in order to lift the box off the floor, or if you're simply holding something steady above the floor, like if you're just holding something in your hands, you're exerting a force that counteracts the gravitational force that is pulling it down. And the force that you're exerting is the weight of the object. That's what weight is. So in this case, if I want the weight, it's basically how much force is being applied in order to hold this thing up. So basically, here is one force. It's 140 pounds at an angle of 65.5. Okay, now for the other one, I can draw it in the same direction. It really doesn't matter what direction I draw it, because so the other one has an angle of 58.3. So I can draw it here, right? But it really doesn't matter because what I'm going to take from both of them is the Y component of the force. Because in both cases, the Y component points up, it really doesn't matter if I draw that second force like this or if I draw it like this. So this one is going to have an angle of 58.3 and it's 115 pounds. So now let's talk about what the Y components of these forces are. So in the one case, we'll call this one F1. So I want F1 Y component. This is going to be 140 sine 65.5. And then if I call this one F2, the Y component of that one is going to be 115 sine 58.3, and the weight is the combined vertical components. Okay, so that's going to be F1y plus F2y, and together the weight is 225.238 pounds. Okay. So next, Walter is kayaking across a river that has a current of 2.5 meters per second. He is paddling at a rate of 4 meters per second, perpendicular to the shore. Okay, what is the resultant velocity of the kayak? So what happens here is Walter is kayaking at a rate of 4 meters per second, perpendicular to the shore. And then there is a current 2.5 meters per second. So the current is obviously going to like push him a little bit to the right. So the resultant velocity will be this. This is the resultant. Now what we want is how much is that resultant? Okay, so in this case, the current has components of 2.5 comma 0. And then what is this? This is the kayak. This has components of 0 comma 4. So the resultant is going to be, when I add the two of them, right? This is going to be C plus K. It's going to be 2.5 comma 4. And then what I want is the magnitude of the resultant. That's the resultant velocity, the magnitude. So that's 2.5 squared plus 4 squared. And I believe that will be 4.7 meters per second. Okay, at what angle will Walter be moving with respect to the shore? Okay, so let's take a look. So if I have, so we can draw this in a variety of ways, right? I have 4 here and 2.5 here. I could also draw this. So this is the resultant vector. Now look, what I can also do is I can make the vertical and the horizontal this way. And if I wanted this angle theta, because that's the angle from 0 with the shore, right? Like just like here, then what this will be is inverse tangent of 4 over this one, 2.5. And you just have to plug that in your calculator. And it should be 58 degrees. Okay, so if Walter wants to land directly in front of his starting point, at what angle with respect to the shore should he kayak? So he means to go this way. However, he lands at an angle that is 58 degrees from here. So if this is 58, this is 32 degrees, right? Because together that makes 90. And so what he needs to do is he needs to now correct his course by 32 degrees. So he needs to point this way, 32 degrees. That would make this 58. So really his angle should be this black one, which is 180 minus 58, which is 122 degrees. Okay. Jordan is riding the bus to school. The bus travels north for 4.5 miles, then east for 2 miles, then east for 2 miles, and then 30 degrees north of east for 1.5 miles. So that's if this is the horizontal, 30 degrees north of east, that's this way, for 1.5 miles, so just a little bit. Express Jordan's commute as a linear combination of unit vectors I and j. So basically, like, that's what we want. Okay, so first we have 0, comma 4.5. That's the first one. The second one is 2, comma 0. And then the third one is 1.5 cosine 30, 1.5 sine 30. So this one will be sine 30 is a half, and then cosine 30 is root 3 over 2. So obviously that's something that needs to be done on the calculator. And so this is going to be equal to 1.3 and 0.75. And then if I label these like vector A, vector B, vector C, then the resultant is A plus B plus C, so that's 3.3, and then 4.5 plus 7.5, so that's 5.25. Sorry, this is 0.75. So R is 3.3I plus 5.25J. Okay, so two clay pigeons are thrown at the same time. The path of the clay pigeons can be represented by these two vectors. What was the measure of the angle between the clay pigeons? Okay, so this is very straightforward. The angle between any two vectors is cosine theta, and then it'll be P dot C over magnitude of P, magnitude of C. So here, if I do P dot C, that's going to be 42 times 59 plus 58 times 73. That's 6,712. And then the magnitude of P is 93.9. The magnitude of C is 71.6. Putting it all together, theta is inverse cosine of 6,712 over 93.9 times 71.6. And obviously, these two we're going to not round. We're going to like save them in the calculator. So then theta ends up being about 3 degrees. Sophia is pushing a shopping cart with a force of 125 newtons at a downward angle or angle of depression of 52 degrees. So if this is the shopping cart, she's pushing at an angle of depression of 52 degrees with 125 newtons. How much work in joules will Sophia do if she pushed the shopping cart 200 meters? Okay, so if that's 52 degrees, then if I do this, so is this one, right? So we want work. So in a situation like this, we know work is F dot D. In a situation like this, when I'm given, the angle and the magnitude, it's best to do F D cosine theta. So in this case, the magnitude of the force is 125. The distance it moves is 200. And then cosine of 52, and this will be 15,391.50 joules. Okay, next. A pilot is carrying a bag weighing 150 newtons up a flight of stairs. The staircase covers a horizontal distance of 8 meters and a vertical distance of 7.5 meters. So basically, like, this is the staircase like this. Okay. What is the length of the staircase? What we want is this, right? And obviously this L is just the Pythagorean theorem. So it's going to be the square root of 8 squared plus 7.5 squared. And we put that in our calculator and it will be about 11 meters. What is the measure of the angle made by the staircase? So now I want the angle made by the staircase, which is this one. So that's going to be inverse tangent of 7.5 over 8. And that is 43 degrees. And that is all we need to know from here. Okay, so we can stop right here.